Hello everyone, welcome to the session of C and data structures. In this session, let us learn how to implement singly linked list, as we have already gone through the theory part and understanding of how a singly linked list work and what it is. Now let's implement the singly linked list. I'm creating a file, the name SLL, that is singly linked list, with a .c extension over here. Let's start typing the code. The first thing that we would do is include our header files, that is hash include stdio.h and hash include lib.h. stdlib.h. Right after this, we require to have a particular structure that consists of two parts for a singly linked list. We will name the structure as SLL, and within this we will have the two parts. One is the data part, which is an integer type. Another one is a self-referential structure. The self-referential structure consists of the same name of that of the structure and a pointer. So basically this particular self-referential structure is nothing but it is a pointer to its own structure. So I'm having a pointer which is basically of the type of its own structure. So this particular structure is known as a self-referential structure, basically used to hold the address of the other node. That is, the link part would be created with the help of this particular self-referential structure. So let's quickly close out this structure and let's try to give a new name to the already existing data type, that is nothing but struct SLL. Since the name struct SLL will be long to be used everywhere whenever we are allocating memory and doing anything for the matter, we would be giving a shorter and simpler name to the structure that we have declared right here. So by using the type def, we are going to just say struct SLL and going to provide a new name, that is node. From now onwards, we can make use of node as the structure name, which can be replaced by node. Wherever struct SLL is required, we can make use of the new name given to the structure, that is nothing but node. Now, I'm going to declare two pointers. As I told you, there are going to be two pointers. The first pointer that is pointing to null as of now because I have no nodes created here, and the second pointer would be named as last, which is going to be always pointing to my last node, and as of now it is been pointing to null because I have not yet created any nodes in my linked list. Now let's write the function definition for creating a node. So basically I would say void create node, within which I would be passing on one element which is known as ELE, the formal argument, and within this I'm going to consider node star new is equal to node star malloc is equal to node star malloc size of node. Right after this, I would be considering the next statement if my first is equal to null. If this is equal to null, I would say new of the data part is equal to the element and new of the next part is equal to null, and then we have the next thing, that is last first is equal to null, new, first equal to last equal to new is equal to new. Now this is the functionality that I would be writing for creating my node. So with the help of my main function, I would make a call to this particular function, which is nothing but create node, and the value that I would be passing inside create node would be 10. So immediately what would happen is, As soon as my program starts execution, it starts from main and there is a call to the function create node by passing the value 10. It would immediately go and bind with the function definition of create node. The value 10 is being collected inside the element and I am allocating a memory to a pointer new. And to whom I am allocating a memory? I am allocating a memory to the structure. I would be typecasting it into node by using the malloc function. I am allocating memory to the entire structure, which consists of two parts, that is the data part and the address part, and the pointer new is pointing to that particular node. So immediately there will be an address given 100 to this particular node. So right after that I'm checking if my first is equal to null. Right now my first is pointing to null, so null equal to null condition tends to become true. Now what I have to do is I have to provide the data and the address part to the node. So I'm saying new of data, that is to the new node, new of data, that is 100 of data part. I'm providing it with element and the element is nothing but 10. Right after that I'm saying new of next, that is 100 of the next part. I'm assigning it with null because this is the only node that is being created. I do not have a next node for this particular node. So basically we have only one node. So in that case we are making the next part of my new node as a null. Next I'm saying first is equal to last equal to null. That means I'm making my first pointer point to new and I'm making my last pointer also point to the new node because this is the only node and the first and the last nodes are considered to be the same node. So I'm making my first and last pointer point to this particular new node, that is nothing but our address 100. Now right like this, I want to create one more node, or let's say I want to create two more nodes. So imagine that I'm making a call to create node function once again, create node function once again, and this time I'm passing a new data value that is 20, and right after that I'm making a call to the create node function once again, and this time I'm passing the value 30 over here. Now right after this first function call has completed its task, it goes to the next function call over here. Again the function is getting bind over here, gets invoked to create node, and then the value 20 is collected inside this particular variable called as element, and the new memory is getting allocated, that is a new node will be created anywhere in the memory. So let's consider the address to be 200. So the new pointer allocates a memory of two parts, that is the data part and the address part, and the address of the particular new node is going to be considered as 200 and the pointer new is pointing to the node 200. Right after this we have the next part, that is if first is equal to null. Right now my first is not pointing to null, it's pointing to 100 as you can see in the diagram over here. So 100 equal to null, the condition particularly fails. So if the condition fails, so it is not going to perform these operations right here. So immediately what happens is it's not going to execute this part. So we have to write on an else part if we have created an already existing node. So in that case I would say else. Within else I would just say, within else I'm going to say new of the data part is equal to element, new of next part is equal to null, and last of next part will be equal to new, and then I'm gonna say last is equal to new. That's it. So what would happen over here when this particular if condition is failing? That means I would go and bind with the else part, and the new node now is pointing to the address 200. So 200 of the data part will be inserted with the value 20, and that is new of next part, that is 100 of the next part. Currently I do not have another next node over here, so I consider this part to be as a null, and then I'm saying last of next. Now since I have created a new node over here, then I need to attach both of these nodes by using a link. So I'm going to say last of next, that is nothing but 100 of next part wherein it was null previously. Now it is going to link up with a new node, and so it is going to hold the address 200 inside the node, and a link is established between the first node and the next node. And now we can see that it is this particular first node is no more my last node, because I have created a new node, and this new node will be considered to be as the last node now. And I'm going to move my last pointer to the newly created node, that is 200. Right after the execution of this part, my control transfers back from where it was previously called, and it would see that there is another function call. Again it goes back here and it will execute the same code and it will generate another node. So let's quickly understand how to write a display function of this particular node. So basically over here we are not displaying anything. We have just created 3 nodes by establishing link from one to another. To make sure that we have created 3 nodes, we need to write the display function to display the output on the console to understand that the nodes are sequentially created. So let's understand. I need to use a void display function, and we do not pass any arguments here. Right after this, I'm going to take a temporary pointer, because my first and last pointers are always pointing to the first and the last node. They won't be moving anywhere apart from first and last node. So I need to make use of the temporary pointer. So I'm going to take a pointer temp, which is pointing to my first node. Now remember that no matter whatever you're doing with respect to your linked list, you should always make sure that you're accessing your linked list sequentially. Sequential access is really important to move from one node to another node. So in that case, I'm going to make my temporary pointer first point to the first node, and then I'm going to write a while loop wherein I'm going to say while my temp is not equal to null. Till my temp is not equal to null, I have to be looping on and printing the data part of each node. So I would quickly tell printf, pass the format specifier, and then say temp of data is required to be printed. Now why do I use this this particular arrow operator? Because we are accessing the structure data members. So over here also I have used arrow operators. It's because the data and the next part, both of them are the structure data members, and by whom I'm accessing with the help of the pointer new. So if I want to access the data members of the structure via the pointer, I need to be making use of the arrow operator. So here I provide a semicolon, and then right after printing the first element, that is the first data part of the first node, it has to traverse and move to the next node. So I would say temp is equal to temp of next. Right after this, I would close out the while loop and the display function. So basically what happens is, immediately right after this, if I'm making a call to the display function here, if I'm saying display, immediately the control transfers from the function call to the function definition display, and immediately a temporary pointer is pointing to my first, that is 100 over here. Then 100 is not equal to null, condition is true. Temp of data, temp is pointing to 100, 100 of data part is 10, 10 is being printed on my console. Right after that, I'm moving temp equal to temp of next. Now currently my temp is nothing but 100, 100 of next part is 200, so the temporary pointer is pointing to 200 and the loop continues. So 200 is again not equal to null, condition becomes true. Again I'm printing temp of data, that is 200 of data, 20 is being printed on my console. Right after that, my temp is now moving to temp of next, temp is 200, 200 of next is 300. Now again the loop runs, 300 is not equal to null, condition becomes true. Again I'm printing temp of data, that is 300 of data part is 30. After this is printed, I'm moving temp is equal to temp of next. Right now temp of next is null, the loop continues, null not equal to null, the condition tends to become false, and my loop terminates. Right after this, particular control transfers to this particular display function and my program terminates. So I've successfully created 3 sequential nodes in a singly linked list. So let's quickly execute the code and check what would be the output. So I quickly say cc. We have no errors and no warnings in my code. When I execute, I have successfully got 10, 20, 30. So hope you understood the creation of nodes. Thank you.